Oops. So now that we know the zero factor property, let's go apply it to some situations. All right, let me get my little paper up here. All right, and so basically, again, the idea, right, is we're going to factor a polynomial, and that sets up the zero factor property. Each factor gets set equal to 0, and then we solve. And so the first thing we need to do is make sure that my equation, one side is equal to 0 to set up the zero factor property. So in this first example, right, I do have a polynomial equal to 0. Going through our factoring flow chart, I look for a GCF first. There is not one. I see 4 terms, and so because of that, we're going to group it. And be careful, we are grouping around a minus sign. So to group, we group the first 2. And because I'm grouping around that minus, right, we're going to change the signs behind it. All right, and so on this side just continues to be 0. If we continue to factor, we look for a GCF. So we'll factor out an x squared in the front, and it looks like a 9 in the back, right? And so we get x plus 2. Around that minus sign, right, there's a common factor of x plus 2. So I'll factor that out, right? And this is still equal to 0. And that is our difference of squares pattern, right? So when we fully, completely factor this polynomial, we have 3 factors. X plus 2 is a factor, x plus 3 is a factor, and x minus 3 is a factor. ZFP is all set up because I have a product equal to 0. So the ZFP tells us that, well, maybe the x plus 2 is 0, right? Or maybe the x plus 3 is 0, or maybe the x minus 3 is 0. One of those factors has to be 0. Solving, we get one of our solutions, right? X is negative 2. Solving, we get negative 3 is one of our solutions. And solving, we get 3 is one of our solutions. So this equation has 3 solutions. And again, you can check it. Plug in the 3, you'll get 0. Plug in the negative 3, you'll get 0. Plug in the negative 2, you get 0. So there's, again, the zero factor property in action. We got lucky here because everything was set to 0. All we had to do is use our factoring skills. Same one over here. Again, we are already set equal to 0, and I've got a polynomial, so we factor it. Going through our factoring flow chart, I look for a GCF. There is not one. I see 3 terms. There are 3 and it's degree 2. And so basically I have to use my AC method or my guess and check. All right, and just for speed here, I'm going to use the guess and check. So my F and my L, to get the first, that's X and X. And so, to get the L, negative 10, well, how about we use plus 2 and minus 5, okay? And if we check this, right, we get a positive 2x and a negative 5x. And so good news and bad news, right? We get a 3, but it's a negative 3. So how about I scratch that out and say, well, it's actually x minus 2 and x plus 5 is the right one. So first times first is first, last times last is last. The outer's a 5x, the inner's a negative 2x, computed against that middle term. So I found it. Took me a couple guesses, but again, that's what happens when you guess and check. And then, of course, now I have the zero factor property in play because I have a product equal to 0. So maybe that factor is 0, or maybe that factor is 0. Somebody has to be 0. And then we can just basically solve what's left. So 2 is one of my solutions, and negative 5 is one of my solutions. All right, and again, you can check those. Put a 2 in there, we get a true statement. Put a negative 5, you get a true statement. All right, so zero factor property. Number 3, I try to make things a little hard because you'll notice that to start off, one side's not equal to 0. And we'll just fix that, right? We'll just subtract 4 from both sides. And by doing that, right, I now have one side equal to 0. Factoring the polynomial over here, it's a trinomial degree 2. There's no GCF, so we're going to AC it or guess and check it. How about I AC this one since I've done guess and check a couple times. So an ACer, right, you're thinking, all right, well, A is 3 and C is negative 4, so I have negative 12. Right, and so basically we have 2 numbers that multiply up to negative 12, but add up to my b, which is 1. And when we think about it, the numbers that work are 4 and -3. All right, so those two numbers work. As a GCF person, or excuse me, as an AC person, I'm going to factor by taking the first term and last term and leaving them alone, and then breaking up my middle term as 4x minus 3x. And then when I factor by grouping now, we're grouping around a minus sign, so change the signs behind it. On the front end here, it looks like x is common, leaving us with 3x plus 4. On the back end here, nothing's in common but 1, so we just left with a 1. And now across that minus sign, the 3x plus 4 is common, and what's left behind is x minus 1. So that's what a GCF person would do. So going back, so that means that this polynomial, it factors as 3x plus 4 times x minus 1 equals 0. And we have the zero factor property in play. So that means that that factor could be 0, or the other factor is 0. Somebody has to be 0. And here we subtract 4, and then divide by 3. And so one of our solutions is -4/3. Right here we just add 1 to both sides, and we get x equals 1. So that started a little tougher because it wasn't set equal to 0. And then I used the AC method, which is a longer method, right? But it did get us a factorization. And then now that we have a factorization, it's a zero factor property, and we're off to the races. Okay, so last one. Again, I noticed that I have an issue with the neither side's equal to 0. So perhaps if I play the balancing act, I'm going to move everything over to the left. So I'll subtract 8x squared minus 32x from both sides. That's going to leave me with 0 on that side. And then there's no like terms over here. So I have 4x cubed minus 8x squared minus 32x. The reason I moved everything to the left is because we usually like to have our leading coefficient positive. When it's negative, things get a little tricky. So how do I factor this? Well, we always begin by looking at a GCF, and I can see that everybody has at least a 4 in common, and everybody has an x. So 4x is my GCF, and what gets left behind, it looks like x squared minus 2x and minus 8. All right, let me just double check. So there's 4, 8, yep, I think we got it. And then this is a trinomial of degree 2. So how do we factor that? Well, you're either ACing it or you're guessing and checking it. I'm going to guess and check it. First times first is first. To get a -8, how about we say -4 and 2? All right, so my outer is a positive 2, my inner is a -4, that's it. All right, equals 0. So there's my factorization. All right, so we started with the GCF, and then we did a guess and check routine. I have a product equal to 0. So the zero factor property says that one of these guys is 0. So maybe it's 4 times x, or maybe it's x minus 4, or maybe it's x plus 2. But somebody's equal to 0. And then we can solve. Divide both sides by 4, we get 0. Add 4, we get 4. Subtract 2, we get -2. And so there's our 3 solutions. So the moral of the story is, you have to have one side equal to 0 so you can use the zero factor property. If it's already set equal to 0, you start your factoring routine. If it's not set equal to 0, you move things over, and then you do your factoring routine. All right, see you guys in the next video.